The morning of October 21st, 1944, dawned clear and cold over the waters off Cape Engano in the northern Philippines. Captain Sueo Obayashi stood on the bridge of the light carrier Chitose, scanning the horizon for the American task force his reconnaissance aircraft had reported 2 hours earlier. Somewhere beyond that line where the sea met sky, the enemy was coming. But what troubled Obayashi more than the approaching battle was something he had seen 3 weeks earlier in a classified intelligence report that had arrived from Tokyo. American naval analysts had examined wreckage and documentation recovered from a partially sunken Essex-class carrier that had run aground near Ulithi after sustaining torpedo damage. What they found inside that ship had shaken the Naval General Staff to its core. The Americans had not built one Essex, they had not built 5. They had built 24 of them in just 3 years. 24 fleet carriers, each larger and more capable than anything Japan had ever launched. The number seemed impossible. Japan's entire pre-war carrier fleet, built over 2 decades of careful development, totaled 8 ships. The Americans had tripled that number in less time than it took Japan to build a single replacement carrier. Obayashi had read the report twice, certain there had been a translation error or a miscount, but the intelligence was clear and verified through multiple sources. The industrial capacity that could produce 24 fleet carriers in 3 years was not just superior to Japan's. It represented a completely different order of magnitude, a level of manufacturing capability that defied every assumption Japanese naval planners had made about their enemy's limitations. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how Japan discovered America's true carrier production capacity began not with a single dramatic moment, but with a series of incremental shocks that accumulated over 3 years of war. Each shock contradicted what Japanese intelligence had confidently predicted. Each forced a reassessment of assumptions that had seemed reasonable before the war started, and each revealed that Japan had fundamentally misunderstood the enemy it was fighting. In December 1941, when Admiral Chuichi Nagumo's carriers struck Pearl Harbor, Japan possessed the most powerful carrier force in the world. 6 fleet carriers and 4 light carriers, all purpose-built for naval aviation, manned by elite pilots with years of combat experience over China. The Imperial Japanese Navy had invented modern carrier warfare. They had developed the doctrine, refined the tactics, and trained the aircrews that made carrier aviation the dominant force in naval combat. Their confidence was not arrogance. It was based on demonstrated capability and proven performance. The Americans, by contrast, had 7 carriers at the start of the war, only 3 of which were in the Pacific. Their carrier doctrine was less developed. Their pilots had limited combat experience. Their aircraft, particularly the F-4F Wildcat fighter and the TBD Devastator torpedo bomber, were considered inferior to Japanese types in key performance categories. Japanese naval planners believed they had a window of perhaps 18 months to 2 years before American industrial production could replace the losses Japan intended to inflict and rebuild American naval strength to levels that could challenge Japanese control of the Pacific. That calculation was based on careful analysis of American shipbuilding capacity as understood by Japanese naval intelligence before the war. The United States had 9 major shipyards capable of building large warships. Japanese intelligence officers knew their locations, their capacity, and their production rates based on publicly available information from trade journals and technical publications. Newport News Shipbuilding in Virginia was the largest and most capable, having built several of the pre-war American carriers. The New York Navy Yard in Brooklyn had extensive facilities. The Philadelphia Navy Yard and the Norfolk Naval Shipyard were significant construction sites. On the West Coast, the Mare Island Naval Shipyard near San Francisco, the Puget Sound Naval Shipyard in Washington, and smaller private yards in California rounded out the major facilities. Based on observed construction times for pre-war American carriers, Japanese analysts calculated that building a fleet carrier required approximately 3 to 4 years from keel laying to commissioning. The USS Yorktown had taken 32 months. The USS Enterprise had taken 34 months. The USS Wasp had taken nearly 40 months due to design modifications during construction. These were facts, documented in technical publications that Japanese naval attaches purchased openly in American bookstores and subscribed to through legitimate channels. The mathematics seemed straightforward. If America had 9 major shipyards, and each could build one carrier every 3 to 4 years, maximum American carrier production would be approximately 3 new fleet carriers per year, assuming every major yard prioritized carrier construction over all other warship types, which seemed unlikely given American requirements for battleships, cruisers, destroyers, and submarines. Japanese planners assumed that after losing carriers to combat, the Americans would need at least 2 years to restore their pre-war carrier strength and another 2 to 3 years to build enough additional carriers to achieve numerical superiority over Japan's combined fleet. That would give Japan until late 1944 or early 1945 before American carrier strength became overwhelming. The plan was to seize the resource areas of Southeast Asia, establish a defensive perimeter across the Central and Southern Pacific, and force America to either accept a negotiated settlement or face years of costly offensive operations to recapture territory that Japan would defend with every available resource. The strategy was not unreasonable based on the information Japanese planners possessed in December 1941. What they did not know, could not have known without access to internal American planning documents, was that the United States Navy had already completely transformed how it built carriers. The transformation had begun in July 1940, when Congress passed the Two-Ocean Navy Act authorizing massive expansion of American naval forces. The act authorized construction of 11 Essex-class fleet carriers as the foundation of American carrier power. But authorization was only the first step. Building the ships required solving fundamental problems of industrial organization, labor allocation, and manufacturing efficiency that had never been addressed at such scale before in naval construction. The man who solved those problems was not an admiral or a traditional naval architect. He was William Francis Gibbs, a marine engineer who had spent 30 years designing merchant ships and passenger liners. Gibbs understood that building 20 ships using traditional methods, where each vessel was a custom project with unique specifications and hand-fitted components, would take 15 to 20 years. The Navy needed those ships in 4 years. Gibbs proposed something radical that contradicted every principle of traditional shipbuilding. He proposed standardization at a level never before attempted in naval construction. Every Essex-class carrier would be built to identical specifications using identical components manufactured at identical tolerances. Every hull plate would be cut to the same dimensions. Every frame would be bent to the same angle. Every pipe, valve, pump, and electrical fitting would be interchangeable between ships. The components would be manufactured at industrial facilities across the country, shipped to shipyards as prefabricated modules, and assembled like pieces of an enormous puzzle. Traditional shipbuilders called the idea impossible. They argued that warships were complex, highly specialized vessels that required individual craftsmanship and custom fitting. They pointed out that no 2 ships ever came out exactly identical, even when built to the same plans because of inevitable variations in materials and construction methods. They insisted that attempting mass production of warships would result in inferior vessels with lower combat capability. The Navy ignored them. In April 1941, 9 months before Pearl Harbor, the Bureau of Ships issued detailed specifications for the Essex-class that included unprecedented requirements for component standardization and modular construction. Every major system, propulsion, electrical, damage, control, aviation support, would be designed as a self-contained module that could be built separately, tested independently, and installed as a complete unit. The island superstructure, the distinctive command tower that rose above the flight deck, would be prefabricated in sections and welded together during final assembly. The flight deck itself would be built in segments, each segment identical to every other segment across all ships of the class. The innovation was not limited to the ships themselves. The Navy reorganized how shipyards operated, transforming them from craftsman workshops into industrial assembly facilities. Newport News Shipbuilding became the lead yard for the Essex-class. The company received the first construction contract in July 1940 and immediately began reconfiguring its facilities for standardized production. Traditional building ways where ships were constructed from keel to completion were replaced by modular assembly systems. Different sections of each ship, the bow, the stern, the engineering spaces, the aviation support areas, were built simultaneously in different parts of the yard. Workers specialized in specific tasks rather than general shipbuilding. One team would do nothing but weld hull plates, another team would install electrical systems. A third would work exclusively on propulsion machinery. The specialization increased efficiency and reduced construction time dramatically. By June 1942, 6 months after Pearl Harbor, Newport News had cut the construction time for an Essex-class carrier from the estimated 40 months to 26 months. By December 1942, they had reduced it to 20 months. By mid-1943, they were launching new Essex-class carriers every 4 to 5 months. The Japanese knew none of this. Their intelligence on American shipbuilding was based on pre-war observations of pre-war methods. They continued to estimate American carrier production using construction times from 1938 and 1939, when the United States was building carriers using traditional methods at a peacetime pace. The first indication that something was wrong came in August 1942 during the Guadalcanal campaign. Japanese reconnaissance aircraft photographed American naval forces supporting the marine landing and identified the carrier Wasp operating with the carrier Saratoga. Both carriers were known vessels, part of the pre-war American fleet, but the reconnaissance photos also showed a third carrier, whose island superstructure design did not match any known American carrier class. Intelligence officers in Tokyo examined the photographs carefully. The unknown carrier was clearly larger than the pre-war Yorktown class. Its flight deck was longer. Its island was positioned differently. Its anti-aircraft armament was heavier than anything previously observed on American carriers. The only logical conclusion was that this was the first of the new Essex-class carriers that American technical publications had mentioned in 1941. That conclusion was both correct and troubling. If the Americans had already completed an Essex-class carrier by August 1942, they had built it in approximately 14 months, assuming construction started when the Two-Ocean Navy Act was passed in July 1940. 14 months was impossibly fast by Japanese understanding of carrier construction. It suggested either that the Americans had found ways to dramatically accelerate construction, which seemed unlikely, or that they had started building the Essex class earlier than Japanese intelligence had estimated, which would mean more Essex-class carriers were already under construction and would be completed sooner than expected. Japanese intelligence officers chose the second explanation because it seemed more plausible. They adjusted their estimates to assume that America had begun Essex-class construction in early 1940, several months before the Two-Ocean Navy Act was passed. That would give the Americans enough time to complete one carrier by mid-1942. Revising the estimate forward by 6 months suggested that additional Essex-class carriers would begin entering service in early 1943, perhaps 4 to 6 ships by the end of that year. The revision was logical, methodical, and completely wrong. The carrier photographed at Guadalcanal was USS Essex, commissioned on December 31, 1942. She had been built in 20 months, not 14, but by the time she was photographed in August, the United States had already laid down 6 more Essex-class carriers that would be completed within the next 18 months. The second indication came in November 1942, when Japanese submarines operating near Espiritu Santo in the New Hebrides reported multiple large carriers in the harbour, including at least 2 that appeared to be new construction. One was clearly Essex, now identified by name through radio intercepts. The other was unknown but matched Essex's general appearance and size. Tokyo Naval Intelligence received the report and struggled to reconcile it with their revised estimates. If there were 2 Essex-class carriers already in service by November 1942, and if construction time was approximately 2 years as Japanese analysts still assumed, that implied that the Americans had started building at least 2 carriers in late 1940 or early 1941. But American budget documents that Japanese intelligence had obtained through diplomatic channels before the war showed no appropriations for more than one Essex-class carrier until the Two-Ocean Navy Act passed in mid-1940. How could the Americans have started building two carriers before they had funding for more than one? The only explanation that seemed to fit was that American construction methods were significantly faster than Japanese intelligence had estimated. But how much faster? If the Americans could build an Essex-class carrier in 18 months instead of 30 months, they could potentially complete 3 carriers per year from each major shipyard. That would mean maximum annual production of 27 fleet carriers if every major shipyard worked exclusively on carriers. The number seemed absurd. No nation had ever built warships at that pace. The Japanese dismissed it as impossible and settled on a more conservative estimate. They assumed the Americans had developed improved construction techniques that reduced building time to approximately 24 months, still significantly slower than actual American performance, but fast enough to explain 2 Essex-class carriers in service by late 1942. Based on 24-month construction time, and assuming that 6 to 8 Essex-class carriers were under construction at various stages, Japanese intelligence projected that America would have 8 to 10 Essex-class carriers in service by the end of 1943 and perhaps 15 by mid-1944. Combined with surviving pre-war carriers, that would give the Americans a total carrier force of approximately 18 to 20 ships by mid-1944, enough to achieve numerical superiority over Japan's combined fleet, but not so overwhelming that the war became hopeless. The estimate was presented to senior naval leadership in Tokyo and incorporated into operational planning. It was systematic, professional, and wrong by a factor of 2. The truth began to emerge in March 1943 when a Japanese reconnaissance aircraft photographed the Puget Sound Naval Shipyard from high altitude during a long-range mission intended to assess American strength in the Pacific Northwest. The photographs showed 4 large carriers under construction simultaneously at a single shipyard. 4 carriers at one yard meant the Americans were building far more carriers than Japanese intelligence had estimated. If Puget Sound alone had 4 under construction, and if other major yards had similar numbers, total American carrier production could be 20 or 30 ships, not the 8 to 10 that Japanese analysts had projected. The photographs reached Tokyo in April 1943 and triggered intense debate among intelligence officers about how to interpret them. Some argued that the carriers visible at Puget Sound represented the bulk of American construction, with most other yards focused on cruisers, destroyers, and support vessels. Others argued that if one yard had 4 carriers, other yards probably had similar numbers, implying total production far beyond anything Japan could match. The debate was settled, temporarily, by assuming a middle position. Japanese intelligence revised their estimate to project that America would complete approximately 20 Essex-class carriers by the end of 1944. Combined with surviving pre-war carriers and converted light carriers, that gave the Americans a projected strength of 28 to 30 carriers by late 1944. It was a massive force, larger than anything Japan could hope to match, but it was at least comprehensible within the framework of how Japanese planners understood industrial capacity and shipbuilding. The estimate was still wrong. By the end of 1944, the United States would have 32 fleet carriers in service, including 17 Essex-class carriers and 15 other fleet carriers of various classes. But the Japanese would not learn that until much later, and by then the knowledge would change nothing, because the mathematical impossibility of winning had already become obvious to anyone who understood the numbers. The moment when Japanese naval intelligence fully understood what they were facing came not from reconnaissance, photographs, or submarine reports or radio intercepts. It came from examining the wreckage of an American carrier that had been partially destroyed in combat and subsequently abandoned by its crew. In September 1944, the escort carrier USS Shelton was struck by a Japanese torpedo during operations near Morotai in the Netherlands East Indies. The torpedo caused catastrophic damage to the ship's engineering spaces, and the crew abandoned ship after determining that the vessel could not be saved. The carrier remained afloat but heavily flooded, drifting slowly toward the Philippine coast. Japanese naval forces located the drifting carrier 2 days after it was abandoned and sent a salvage team aboard to recover intelligence materials and assess whether the ship could be towed to a Japanese-controlled port for examination. The salvage team spent 8 hours aboard the wreck before determining that the ship was too heavily damaged to save. But during those 8 hours, they photographed everything they could find and recovered several crates of documents that had not been destroyed before the American crew evacuated. The documents included maintenance logs, personnel rosters, communications files, and, most significantly, several copies of internal Navy publications that listed current ship production and commissioning schedules. One document, a logistics planning guide used by supply officers to coordinate parts delivery and personnel assignments, included a comprehensive list of all Essex-class carriers, their hull numbers, their construction yards, and their commissioning dates or projected commissioning dates for ships still under construction. The list showed 24 Essex-class carriers. The first 8 were already in service. The next 10 were under construction at various stages of completion, with projected commissioning dates ranging from October 1944 through March 1945. The final 6 were in early construction, with commissioning projected for mid to late 1945, 24 carriers, all of them Essex-class. All of them built or being built in just 3 years since the first ship was laid down in April 1941. The documents reached Tokyo in early October 1944. Senior intelligence officers read them, reread them, and checked them against every other source of information available about American carrier strength. The numbers matched reconnaissance reports of carriers observed in various Pacific anchorages. They matched radio intercepts that had identified multiple Essex-class carriers by name. They matched prisoner interrogations where American sailors had casually mentioned serving on carriers that Japanese intelligence had not previously known existed. The documents were authentic, the numbers were real, and they meant everything Japanese intelligence had estimated about American industrial capacity was fundamentally wrong at the most basic level. Captain Takeshi Naito served in the intelligence section of the Naval General Staff and was responsible for analyzing American naval production. He was the officer assigned to prepare a formal assessment of what the Essex-class production numbers meant for Japan's strategic situation. Naito's report, submitted on October 15, 1944, was remarkable for its clarity and its bleakness. The report began by acknowledging that previous intelligence estimates of American carrier production had been systematically low throughout the war. The reasons for the errors included underestimation of American shipbuilding capacity, failure to recognize how quickly American industry could scale up production, and inability to comprehend construction methods that were fundamentally different from Japanese approaches. Naito then walked through the mathematics of what 24 Essex-class carriers meant in practical terms. If the Americans could build 24 fleet carriers in 3 years, their annual carrier production was 8 ships. Japan's total carrier construction during the same 3-year period, including fleet carriers, light carriers, and escort carriers converted from other hull types, totaled 6 ships. The Americans were building carriers 4 times faster than Japan. But the disparity was actually worse than that ratio suggested, because American carriers were larger and more capable than most Japanese carriers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. An Essex-class carrier displaced 27,000 tons, carried 90 to 100 aircraft, and had a crew of approximately 2,700 officers and enlisted personnel. The ship could sustain high-speed operations for extended periods, conduct flight operations in sea states that would ground smaller carriers, and absorb battle damage that would sink lighter vessels. Japan's newest fleet carrier, Taiho, displaced 29,000 tons, and was comparable in capability to the Essex-class. But Japan had built 1 Taiho. The Americans had built 24 ships of equal or greater capability. The Unryu class of fleet carriers, Japan's answer to the Essex-class, was designed to displace 17,000 tons and carry 65 aircraft. 3 had been completed by October 1944. Another 3 were under construction. Even if all 6 were completed, which seemed unlikely given Japan's deteriorating industrial situation. They would represent half the capability of 6 Essex-class carriers. NATO's report included a detailed comparison table that laid out carrier strength as of October 1944 and projected strength assuming both sides continued building at current rates. As of October 1944, Japan had 4 operational fleet carriers and 4 operational light carriers, a total of 8 carriers capable of offensive operations. The United States had 17 Essex-class carriers in service, 7 other fleet carriers of various classes, and 9 light carriers, a total of 33 carriers capable of offensive operations. The American advantage was 4-1 in absolute numbers and probably 6-1 in effective combat capability, given the superior size and aircraft capacity of American carriers. Looking forward, if current production rates continued, by June 1945 Japan would have perhaps 6 operational fleet carriers, assuming the remaining Unryu-class carriers were completed without delay. The United States would have 24 Essex-class carriers, 7 other fleet carriers, and 9 light carriers, 40 carriers total. The American advantage would increase to 7-1. By December 1945, assuming Japan somehow maintained production despite bombing, resource shortages, and damage to industrial facilities, Japan might have 7 operational fleet carriers. The United States would have 30 Essex-class carriers, plus other classes, probably 45 to 50 carriers total. The ratio would approach 8-1. NATO's conclusion was direct and unambiguous. Japan could not win a carrier war against the United States. The numerical disparity was already insurmountable and would only grow worse over time. Every month that passed increased American advantages in numbers, in pilot training capacity, in aircraft production, in logistics support, and in combat experience. Japan's carrier force had been reduced to 4 operational ships after losses at Midway, Philippine Sea, and through submarine attacks. Those 4 carriers were manned by pilots with minimal training and equipped with aircraft that were increasingly obsolete compared to American types. Even if Japan built additional carriers, there were no experienced pilots to fly from them, and no fuel to train replacement pilots adequately. The industrial capacity to build carriers was meaningless without the personnel to operate them and the resources to sustain operations. NATO recommended that the Naval General Staff accept that carrier operations against American forces were no longer viable as primary strategy. Japan's remaining carriers should be used as decoys or in support roles where their loss would not represent irreplaceable losses of trained personnel. Primary emphasis should shift to land-based aviation operating from shore bases that could not be sunk, defended by dispersed aircraft that could not be destroyed in a single battle, and supported by logistics networks that did not depend on vulnerable surface vessels. It was a desperate recommendation, born of desperate circumstances, but it was also the only realistic assessment of Japan's strategic situation, given the carrier production numbers that had finally been confirmed through captured documents. Senior naval leadership read NATO's report. They understood his analysis. They recognized that his conclusions were mathematically sound, and they chose to continue offensive carrier operations anyway because admitting that carrier warfare was no longer viable would have required admitting that Japan had lost the war. Institutional momentum, cultural expectations of offensive action, and political inability to accept defeat meant that accurate intelligence did not change strategic decisions, even when those decisions were leading toward certain catastrophe. On October 25, 1944, 4 days after Captain Obayashi had stood on Chitose's bridge, contemplating the intelligence report about American carrier production, the Battle of Cape Engano concluded with the destruction of Japan's remaining operational carrier force. Chitose was hit by repeated bomb and torpedo strikes from American carrier aircraft and sank in the early afternoon, taking Captain Obayashi with her. The light carriers Zuiho and Chiyoda were sunk within hours. The fleet carrier Zuikaku, the last surviving carrier from the Pearl Harbor attack force, absorbed multiple bomb hits throughout the day before finally capsizing and sinking in the late afternoon. Her crew sang the national anthem as the ship went down. a final gesture of defiance against an enemy whose industrial power had rendered such defiance meaningless. The 4 carriers sunk at Cape Engano represented Japan's last operational carrier capability. There were other carriers in Japanese ports, some under repair, some awaiting aircraft and pilots that would never arrive, some simply lacking the fuel to sortie. But as effective combat units capable of conducting offensive operations, Japan's carrier force ceased to exist on October 25, 1944. The Americans lost no carriers at Cape Engano. They lost some aircraft and some pilots, losses that would be replaced within days from training commands that graduated new aviators by the hundreds every month. The task force that destroyed Japan's carriers included 6 Essex-class carriers among its composition. Those 6 ships represented 1/4 of the total Essex-class production at that point. The Americans had 18 more Essex-class carriers, either already in service or under construction, with commissioning dates scheduled through mid-1945. Japanese naval intelligence officers monitoring American radio traffic in the weeks after Cape Engano identified Essex-class carriers operating in the Philippine Sea, in the waters off Formosa, near Iwo Jima, and in support roles across the Central Pacific. The ships were everywhere, operating simultaneously in different theaters, sustaining combat operations without apparent strain on American logistics or maintenance capabilities. Each carrier represented 20 months of construction time, 27,000 tons of steel, 2,700 trained personnel, and 90 combat aircraft. Each was a self-contained mobile airbase capable of projecting American power across hundreds of miles of ocean, and there were 24 of them, with more joining the fleet every month. How had the Americans done it? The question haunted Japanese officers, who understood what the numbers meant. How had a nation built 24 fleet carriers in 3 years, when Japan, with its proud shipbuilding tradition and decades of carrier design experience, had struggled to build 6 carriers of all types during the same period? The answer lay not in any single innovation, but in fundamental differences in how the 2 nations approached industrial production and military mobilization. Japan built carriers the way it had always built warships, as individual projects crafted by skilled workers using traditional methods adapted from centuries of maritime construction. Each carrier was unique, incorporating lessons from previous ships but requiring new calculations, new measurements, and new custom-fitted components for every section of the hull. The Japanese approach produced excellent ships when completed. Carriers like Shokaku and Zuikaku were beautifully designed vessels that performed superbly in combat when they had adequately trained crews and properly maintained aircraft. But the approach was slow, labor-intensive, and dependent on skilled craftsmen who required years of training and could not be rapidly expanded in number when war demanded increased production. The United States built carriers using principles borrowed from automobile manufacturing and applied to shipbuilding at a scale never before attempted. The Essex-class design was finalized once, and then frozen. No modifications were permitted during construction except for critical safety improvements. Every carrier built to Essex-class specifications would be identical to every other carrier in that class. That standardization meant that workers did not need to be skilled shipbuilders who understood the entire vessel. They needed to know how to perform one specific task, weld a particular type of seam, install a specific component, or assemble a prefabricated module, and perform that task repeatedly until it became automatic. The standardization extended beyond the ships themselves to the components that went into them: electric motors, pumps, valves, piping, ventilation systems, radar equipment, communication systems, and damage control equipment were all manufactured to identical specifications at facilities across the United States. A replacement pump for an Essex-class carrier could be pulled from warehouse stock and installed without modification because it was guaranteed to fit exactly like the pump it replaced. Japan lacked that level of industrial standardization. Japanese carriers used custom-built components designed specifically for each vessel. Every replacement part had to be manufactured individually or modified to fit the specific ship that needed it. The logistics burden was enormous, and became unsustainable as the war progressed, and Japan's industrial capacity eroded under American bombing and submarine blockade. American shipyards operated with a clarity of purpose that Japanese yards never achieved during wartime. Once the Essex-class design was finalized, yards could focus entirely on optimizing the construction process without worrying about design changes or modifications. Workers became more efficient with each ship built. Newport News Shipbuilding launched its first Essex-class carrier, USS Essex, in July 1942 after 20 months of construction. The yard launched USS Intrepid in April 1943 after 18 months. USS Hornet was launched in August 1943 after 16 months. Each successive ship took less time because the yard had learned how to build them more efficiently. By late 1943, Newport News was building Essex-class carriers in 14 months, from keel laying to launch. Japanese yards showed the opposite pattern. Each successive carrier took longer to build than the one before because resources became scarcer. Skilled workers were drafted into combat units, and American submarines destroyed increasing percentages of materials being shipped to shipyards from resource areas. Taiho took 32 months to build. The first Unryu-class carrier took 28 months, the second took 31 months, the third took 35 months, and was still incomplete when the war ended. Construction times increased even though the ships were smaller and less complex than Taiho, because the industrial base supporting construction was deteriorating faster than yards could compensate. American carrier production was supported by an industrial infrastructure that operated at continental scale. Steel mills in Pennsylvania, Indiana, and Ohio produced the hull plates and structural steel. Machinery manufacturers in Connecticut and Massachusetts built turbines and generators. Electronics. Companies in New York and New Jersey manufactured radar and communication equipment. All of this material moved by rail across a continent connected by hundreds of thousands of miles of track to shipyards on both coasts that could receive deliveries without worrying about submarine attacks or air raids. Japan's industrial base was concentrated in relatively small areas along the coast that were increasingly vulnerable to American bombing and submarine interdiction. Steel production depended on iron ore from Manchuria and Southeast Asia that had to be shipped across waters patrolled by American submarines. Every stage of the production process was constrained by transportation bottlenecks and resource shortages that worsened steadily as American forces captured island bases, tightened the submarine blockade, and began systematic bombing of Japanese industrial facilities. By mid-1944, Japanese carrier construction had essentially stopped, despite several carriers being in various stages of completion. American carrier construction continued at full pace through 1944 and into 1945. Essex-class carriers joined the fleet at a rate of approximately one per month from mid-1943 through early 1945. Each new carrier was fully equipped, fully manned, fully stocked with aircraft, ammunition, fuel, and supplies, and ready for immediate deployment to combat operations. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The captured documents that revealed Essex-class production numbers also revealed something else that Japanese intelligence found almost as troubling. The documents showed that Essex-class construction was only one part of a much larger carrier program. The Americans were simultaneously building light carriers, escort carriers, and an entirely new class of large carriers designated the Midway class that would be even larger and more capable than the Essex class. The Midway-class carriers would displace 45,000 tons, nearly twice the size of an Essex-class carrier, and carry 120 aircraft. Even after building 24 Essex-class carriers, the Americans were developing next-generation carriers that would make the Essex-class obsolete by comparison. Japanese naval officers reading these reports understood that they were not facing an enemy that had built to a certain level and would then stop. They were facing an enemy whose industrial capacity was so vast that building 24 fleet carriers had not strained that capacity in any meaningful way. The Americans were building carriers because they chose to build carriers, not because they were devoting every available resource to the effort. The Essex-class program represented a small fraction of total American naval construction, yet it alone exceeded Japan's entire warship building capacity by a factor of 4 to 1. Captain Toshikazu Omai served on the carrier Zuikaku and survived when the ship sank at Cape Engano. After the war, Omai wrote extensively about his experiences and his understanding of why Japan lost. He described the moment when he truly understood what Japan was fighting. It was not at Cape Engano when his ship was sinking. It was weeks earlier when he had read the intelligence report about Essex-class production. Reading that the Americans had built 24 carriers in 3 years was like reading that someone had learned to breathe underwater. It seemed to violate basic physical laws of what was possible. But the numbers were verified. The ships existed. They were operating in the Pacific, attacking Japanese bases, sinking Japanese ships, and destroying Japanese aircraft. Omai realized that Japan had never had any chance of winning the war. Not because Japanese sailors were inferior or because Japanese ships were poorly designed, but because Japan was fighting an enemy whose industrial capacity was so far beyond Japan's own that the war was mathematically unwinnable from the first day. The Americans could lose carriers and build replacements faster than Japan could sink them. They could lose pilots and train replacements faster than Japan could kill them. Japan had no reserves. Every loss was permanent. Every carrier sunk removed capability that could never be replaced. Every pilot killed represented years of training lost forever. The Essex-class production numbers made all of this mathematically explicit. 24 American carriers versus 4 Japanese carriers meant 6 American carriers for every Japanese carrier. If Japan sank 2 American carriers, which represented extraordinary success, the Americans would still have 22 carriers remaining, and Japan would still have 4. The math never worked in Japan's favor. The intelligence failure regarding Essex-class production was ultimately a failure of imagination rather than a failure of information collection. Japanese intelligence officers had access to most of the information they needed to estimate American carrier production more accurately. American technical publications described shipyard capacity and construction methods. American newspapers reported ship launchings. The raw information was available. What was missing was the ability to imagine industrial production at a scale that Japan had never experienced and could not replicate. Japanese planners looked at American shipyards and saw facilities similar to Japanese yards, perhaps larger and more numerous, but fundamentally operating on the same principles with similar constraints. They could not conceive of shipyards that operated like automobile factories, building ships from standardized components using semi-skilled labor that learned specific tasks rather than mastering entire crafts. They could not imagine logistics networks that could deliver millions of tons of supplies across thousands of miles of ocean to maintain fleet operations indefinitely. These capabilities existed nowhere else in the world. No other nation in 1944 could build carriers at American rates or sustain carrier operations at American scales. By December 1944, the strategic situation was undeniable. American carrier strength had reached 32 fleet carriers, with more joining monthly. Japanese carrier strength had been reduced to 0 operational fleet carriers. American carriers operated freely throughout the Pacific, attacking targets at will. Japanese industry was collapsing under American bombing and submarine blockade. Cities were being burned by B-29 raids. The home islands faced invasion by forces so large that Japan could not hope to defeat them. The knowledge that America had built 24 Essex-class carriers in 3 years crystallized why defeat was inevitable. It explained why American forces appeared everywhere, simultaneously. It explained why losing battles never seemed to diminish American strength, because replacement ships and aircraft arrived faster than Japan could sink or destroy them. It explained why every Japanese victory was temporary and every Japanese defeat was permanent. The final Essex-class carrier, USS Philippines Sea, was commissioned on May 11, 1945, 3 months before Japan surrendered. She was the 24th and final ship of the class. Philippines Sea never saw combat. By the time she completed training, the war was effectively over. The fact that the final Essex-class carrier never fought was perhaps the most eloquent statement of American industrial dominance. The United States built 24 fleet carriers because it could, not because it needed all of them. The story of how Japan discovered that America had built 24 Essex-class carriers in 3 years is ultimately a story about the limits of intelligence in war. Good intelligence can identify enemy capabilities, but intelligence cannot compensate for fundamental disparities in industrial capacity. Japanese intelligence officers eventually discovered the truth about American carrier production. They compiled accurate reports. They presented a clear analysis. And none of it mattered because the system was incapable of acting on information that contradicted the fundamental assumptions on which the entire war effort was based. The 24 Essex-class carriers represented industrial power at a scale that Japan could not match and could barely comprehend. 24 fleet carriers built in 3 years demonstrated that America's industrial capacity operated at a level that made conventional military resistance futile for any nation that lacked comparable resources. The numerical superiority meant that Japan could never achieve decisive victory, even if Japanese forces won individual battles. Every engagement was a battle of attrition, and attrition always favored the side with greater reserves. By late 1944, Japan had no reserves. America's reserves seemed unlimited because they essentially were unlimited for practical purposes. The final assessment must acknowledge both the remarkable nature of the achievement and the brutal mathematics it represented. Building 24 fleet carriers in 3 years required innovations in industrial organization that transformed naval construction. The United States possessed all of these capabilities. Japan possessed none of them. That disparity determined the outcome of the carrier war in the Pacific. The 24 Essex-class carriers were the physical manifestation of American industrial power, applied to military purposes with ruthless efficiency. Each ship represented the industrial infrastructure that made such construction possible. The United States built the carriers and then supported their operations without apparent strain. That capability, more than any individual battle, was what defeated Japan. The Japanese Navy examined the wreckage, recovered the documents showing Essex-class production, and understood that they had been fighting an enemy whose capabilities exceeded their worst estimates. Understanding that truth did not change the war's outcome, because by September 1944, the war was already lost. But the truth explained why Japan lost, not because of tactical failures or strategic mistakes, but because Japan had challenged an industrial superpower whose capacity for wartime production operated at scales that Japan could not match regardless of courage, skill, or determination. The numbers tell the story with brutal clarity. Japan built 6 carriers during 3 years of war. America built 24 carriers of a single class during the same period, plus dozens of other carriers. The ratio represented industrial superiority so complete that military resistance became futile once American production reached full capacity. For Japanese naval officers who understood these numbers, the question was never whether Japan would lose, but only when surrender would come. The carriers were the instruments of victory, not because they were individually superior to Japanese carriers, but because there were so many of them that Japanese forces could never achieve more than local, temporary successes that changed nothing about the war's ultimate trajectory. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.